స్టార్ట్ చేస్తాం.
Good morning, students. Today we are going to discuss about megasporangium or ovule. So my question is, what is ovule? Integumented megasporangium is nothing but ovule. What is ovule? Integumented megasporangium is called ovule. What is ovule, ma? Integumented megasporangium is called ovule. Yes. So ovule is a small structure. It is attached to placenta by a stalk-like. Ovule is a small structure. It is attached to stalk-like structure within the ovary, that is called placenta. Ovule is a small structure. Ovule is a small structure attached to stalk-like structure, that is called placenta. But my question is, what is placenta? Where this placenta is present? See, so where ovules are attached inside the ovary, that region or that part is called placenta. See, for example, if we take the carpel, each carpel mainly consists of 3 parts. So we know that what are those 3 parts? Stigma, and this is a style, and this is a ovary. Yes, if we take the transverse section of the ovary of the hibiscus, we can find out 5 locules. We can find out how many locules, ma? 5 locules. 1, 2, 3, 4, 5. But number of locules is equal to number of carpels. Because of that reason, so pentacarpellary, pentalocular, syncarpus, superior ovary, axial placentation is present in the flower of or in the ovary of hibiscus. See, this structure is called placenta. This structure is called placenta. From this part or from this region, ovules are attached. So these are ovules. But these ovules are attached to placenta by a stalk-like structure. See, the ovules are attached to placenta by a stalk-like structure, that is called funicle or funiculus. I hope you are clear. So ovule, integumented megasporangium is called ovule. Ovule is a structure. It is attached to placenta by a stalk-like structure, that is called funicle. I hope you are clear. This is funicle and this is ovule. And this is a placenta. Yes, if we take the structure of ovule or megasporangium, see, so here we discussed that this is the funicle. Yes, this is the stalk-like structure which is attached to placenta by a stalk-like structure, that is called funicle or funiculus. Alright, but if you observe the structure of ovule, ovule has 2 parts. One is ovular body and another one is stalk. This stalk is called funicle. But this ovular body or the body of the ovule is attached to funicle by a structure or by a region, that is called hilum. That is called hilum. Which one, ma? The body of the ovule is attached to funicle in the region that is called hilum. Yes, this one is called hilum. Hence, hilum is considered as a junction between the ovular body and funicle. So this hilum is considered as a junction between ovular body and funicle. Yes, each and every ovule contain 1 or 2 protective layers. Those are called integuments. Which one, ma? So this is the structure of ovule. If you observe the structure of ovule, each and every ovule contain 1 or 2 protective layers. Those are called integuments. Yes. So these are called integuments. But here we have two integuments. One is outer integument and another one is inner integument. So this is outer integument and this is inner integument. Outer integument and inner integument. Yes. So integument encircle the entire ovule except at the tip where small opening is present, that is called micropyle. This is called micropyle. So these integuments encircle the entire ovule except at the tip where small opening is present, that is called micropyle. Opposite to this micropyle is called chalazal end. Opposite to micropyle is called chalazal end. But this chalazal end is considered as the basal part of the ovule. The chalazal end is considered as the basal part of the ovule. Yes. So integuments, within the integuments there is a diploid nutritive tissue. So these are the outer integument and inner integument are integuments encircle a diploid mass of cells. Those are called nucellus. This is called nucellus. This is called nucellus. Yes, if you take the nucellus. So what is the ploidy of the nucellus? The ploidy of the nucellus is a 2n. So 2n is nothing but it contains two set of chromosomes. Hence those are called diploid condition or diploid chromosomes. So what is the use of this nucellus? Nucellus is a nutritive tissue. It contains abundant reserve food materials. This nucellus contains abundant reserve food materials. And a large oval shaped structure embedded within the nucellus towards micropylar end, that is called embryo sac. Which one? Within the nucellus towards the micropylar end, a large oval shaped structure is embedded, that is called embryo sac. This embryo sac is also called female gametophyte. Female gametophyte. At maturity, this female gametophyte contains three parts. So antipodals, synergids, and egg cell and polar nuclei. So we will discuss separately about embryo sac or female gametophyte in upcoming classes. So this is about structure of megasporangium or ovule. I hope you are clear. Yeah, up to now we discussed about structure of megasporangium or ovule. Now types of ovules. So based on the amount of nucellus or depending upon the amount of nucellus, so there are two types of ovules. How many types of ovules, ma? Two types of ovules. Based on which criteria? Based on the amount of nucellus, there are two types of ovules. The first one is teninucellate. And the second one is crossinucellate. Teninucellus and the second one is crossinucellate. Here in this condition, in case of teninucellus, the amount of nucellus is scanty. Amount of nucellus scanty. That means a little amount of or very less amount of the nucellus is present in ovules. Hence those ovules are called teninucellate or teninucellus ovules. The second one is crossinucellate. Yes, in this type of ovules, the amount of nucellus is massive. Amount of nucellus is massive. That means more amount of the nucellus is present. Yes, types of ovules based on the amount of nucellus. There are two types of ovules. The first one is teninucellate or teninucellus ovules, and the second one is cross-nucellus. In case of teninucellus, amount of nucellus is scanty. In case of cross-nucellate, amount of nucellus is massive. Now, based on the number of integuments, there are three types of ovules. This is the first criteria based on the amount of nucellus. The second one is based on the number of integuments. Yes, based on the number of integuments. Based on the number of integuments. Based on the number of integuments. So there are three types of ovules. Based on the number of integuments, there are three types of ovules. Unitegmic ovules. Unitegmic, this is the first one. And the second one is a bitegmic ovule. Bitegmic. And the third one is ategmic ovule. Yes, based on the number of integuments, ovules are how many types? Three types. What are those three types? The first one is unitegmic ovule, and the second one is bitegmic ovule, and the third one is ategmic ovule. Now the first one is a unitegmic ovule. Yes, name itself indicates that uni, number of integuments 1. Ovule with one integument. Ovule with one integument. Yes, ovule with one integument, those are called unitegmic ovules. Examples. So we can find out unitegmic ovules in gamopetale members. Gamopetale members. So for example, sunflower. Sunflower comes under gamopetale. Now the second one is a bitegmic ovule. Bitegmic ovules. Here, what are bitegmic? Ovule with two integuments. Ovule with two integuments. Ovules with two integuments are called bitegmic ovules. So example for this, polypetale, and polypetale monocots. These two members of the ovules exhibit bitegmic ovule, polypetale and monocots. Monocots and polypetale exhibit bitegmic ovules. And the third one is ategmic ovules. A is nothing but absent. Which one is absent? Integuments are absent. The nucellus is not surrounded by any integuments. Which one, ma? Nucellus is not surrounded by any integuments. Hence, these are called ategmic ovules. Examples: Belanophora, Santalum, Loranthus. These are the examples for ategmic ovules. That means ovules without integuments, those are called ategmic ovules, or nucellus is not surrounded by any integuments, those are called ategmic ovules. Example for this: Belanophora, Santalum and Loranthus. These three members exhibit ovules without integuments. This is about types of integuments based on the number of, types of ovules based on the number of integuments. So now we discuss the types of ovules. So the first one is based on the amount of nucellus, and the second one is based on the integuments. So based on the amount of nucellus, two types of ovules. The first one is teninucellate and the second one is cross-nucellate. Based on the number of integuments, three types of ovules. unitegmic ovule, bitegmic ovule and ategmic ovules. Now, based on the position of funiculus in relation to micropyle and chalaza, ovules are of 6 types. Ovules are of 6 types. So, based on the position of micropyle in relation, based on the position of funiculus in relation to micropyle and chalaza, ovules are 6 types. Ovules are of 6 types. The first one is a orthotropous ovule. And the second one is anatropous ovule. The third one is hemianatropous. Hemianatropous. Orthotropous, anatropous, hemianatropous. The fourth one is camphylotropous. And the fifth one is amphitropous. And the sixth one is succinotropous. So, based on the position of micropyle in relation to funiculus and chalaza, ovules are of 6 types: orthotropous ovule, anatropous ovule, hemianatropous, camphylotropous, amphitropous and succinotropous ovules. Now we will discuss each one separately. Now the first one is orthotropous ovule. If we take the structure of orthotropous ovule, here. So, orthotropous ovule is also called erective ovule because micropyle, chalaza and funiculus lies on same line or lies on linear line. Hence, this type of ovules are called erective ovules. There is no degree of the curvature. The degree of curvature is 0. See, this one is a micropyle. And this is a chalaza, and this is the funiculus. This is the funiculus, and these are outer integument, outer, and this is the inner integuments. Outer integument and inner integument, and this is a ES, embryo sac. See here, micropyle and chalaza and funiculus, all the things, 3 micropyle, chalaza and funiculus are arranged on same line. Hence, this type of ovules are called erective ovule or orthotropous ovules. In which members we can find out these orthotropous ovules? For example, this type of ovules are observed in the members of family Piperaceae and Polygonum. In which members we can find out orthotropous ovule or erective ovules? So these type of ovules are observed in the members of Piperaceae and Polygonum. Yes. Now we will start with another type of ovule, that is anatropous ovule. So these anatropous ovules are also called inverted ovules. Anatropous ovules are also called inverted ovules. Yes, my person. Now, anatropous ovule. Yes, now anatropous ovule. If we take the anatropous ovule, see. So, in anatropous ovule, the degree of curvature is 180 degrees. The degree of curvature is 180 degrees. This is embryo sac. In this type of ovules, micropyle is directed towards a funiculus. See, this is the micropyle, but this micropyle is directed towards a funicle. Micropyle directed towards a funiculus. And this is outer integument, and this is inner integument. This is a chalaza. See, the degree of curvature is 180 degrees. What is the degree of curvature, ma? The degree of curvature is 180 degrees. So, where we can find out these type of ovules? So, 82% of the angiosperms exhibit anatropous type of ovules, or this type of ovules. 82% of the angiosperms exhibit anatropous ovules. This is about anatropous ovule. Now the next one is hemianatropous ovule.